Okay. What's up? Draw a picture. That's right. Good job. Okay, so pouring from a chute. So we've got a chute. That's a chute. And you've got... Okay. So see, you've got some grain things here. Oh, maybe you're going to brew some beer. I don't know. Although I guess you wouldn't pour it in a conical pile. Okay, there we go. There's my conical pile. And there's the chute. Okay, so what information what should I label? The height. Okay, so the height of the pile. Maybe I shouldn't ask. I'm just going to label it H. Okay, what else should I label? Radius, okay. I'm again not going to ask. I'm going to label it R. Okay, so what else should I... What else should I write down? Yep. So the rate, so I have 8 cubic feet per minute, right? So what is that? So if I write that down, so what would that be? The derivative of... Nope. What's the first thing I told you guys when we started doing these? What do you look at that tells you what the derivative is?
The speed. I don't know. No, the question. So how fast is the height of the pile increasing?
No, you look at the units, remember?
That's volume over...
Volume, exactly, right? It's cubic feet per minute. So what is that? Cubic feet is a measure of volume, so that's how you know it's the derivative of the volume. Right? Okay. All right, so 8 cubic feet per minute. And then notice we have this other intriguing piece of information. It says that the height is always twice its radius. Well, that looks like important information right there. So how would I write that down? So the height is always twice the radius. H equals 2r, right? Okay, so I'll just keep it there because that looks like it's information I'm going to use. Okay, and then last but not least, this last part, how fast is the height of the pile increasing at the instant when the pile is 6 feet high? So that's my question, right?
Yep.
So what would that be?
What is
dh, right? So how fast is the height? So how fast is the height changing? So dh over dt equals to question mark. When, what? When h equals 6, exactly. And that's my question right there. So that was a pretty good job for the first step. What's the second step? Formula. So which one? Volume of a cone sounds pretty reasonable. Why? Well, because we're given the rate of the volume, right? We're given information about the height and the radius, so there's nothing more natural than choosing the volume. What is the volume of a cone? 1/3 pi r squared h, right? Okay. Now, so that's good. Should I get the derivative of that? What is it? You don't have to mess with it a little, but you should mess with it a little. Because notice that if I get the derivative of both sides there, what would you have to do on the right side? Since you have r and h, and they're both functions of t, what would you have to do? Well, besides from the chain rule, what is r and h, what are they doing with each other? They're multiplying, right, each other, which means when you get the derivative of that, you would have to use the product rule, right, on top of the chain rule. So, so that means the right side would be a mess. But you have some important information. What is it? H equals 2r, exactly. See, over here, you were told that h equals 2r. So that means that you can replace r with h or h with r, whichever one seems more convenient. So which one should we replace? Should we... All right, so the problem is that you guys answered the question way too fast. Oh, wait, sorry. Hold on. Okay, this is the problem. This is... Oh. You replace h with 2r, right? Okay, now you guys probably should not be really writing this down. I'm writing it down just because you guys told me to do that, but we're going to erase it in a minute. Okay, so this doesn't look like there's a problem, and there isn't really, but can you guys see, look ahead where the problem is? You don't have an h. What's the question about? The rate at which h changes. So if I get the derivative of this formula, am I going to get the derivative of h? No. So so you know, you have to you want to be careful here. Make sure that you're you set it up so that you answer the correct question. So let's go back. So here I'm going to use, so not h equals 2r, but instead r equals h over 2. That way I'll have only h's in there, right? Does that make sense? So I'm going to replace r with h over 2. And so then what does that look like? So that's going to be v is equal to pi. So 1/3 pi h over 2 squared times h. So 1/3, well, let's simplify it. So this is going to be 1 over 12 pi h cubed, right? You guys see that? Because the 2 squared on the bottom is 4, right? Multiply that by the 3, you end up with 12 on the bottom. And then multiply the h squared with the h, and you get h cubed, right? Okay. All right. And now we can get the derivative, right? So now this is no problem. So we're on the right track here. No product rule necessary or anything like that. On the left side, we'll have dv over dt, right? On the right, what rule do I have to use there? Which one? I have 1 over 12 pi h cubed. What rule do I use there? Just the power rule, right? Because what's 1 over 12? 1 over 12 is a constant. Pi is a constant. And so 1 over 12 pi, you just leave them alone, right? And then you do the power rule, right? So times 3 h squared, and then dh over dt. Okay, so then we can reduce a little bit. So 12 and 3 reduce to 1 and 4. What else? Do I know dv over dt? That's 8, right? So that's this one right there. What about h? I'm given h, right? Because it says when h equals 6. Right here, right?
Shouldn't pi be crossed off?
How come? Nope. So let's finish it and then we'll talk about it. Because we talked about it last time, but it bears repeating. Okay, so what do we end up with here? We have pi. 6 squared is 36, right? divided by 4. Let's see, am I missing anything? dH over dt. So dH over dt is equal to, well, maybe let's reduce, right? 2 and 18. Well, I guess I should have done 4 and 1 and 9, right? So then what would that be? That would be 8 over 9 pi. Does that make sense? Okay, so back to the question about the constants. So if I get the derivative of a constant, what is that? 0. Okay. But if I have the derivative of a constant times a function, what is that? The constant times the derivative of the function, right?
So if the constant's just by itself, then it's 0.
Right. Because the rate of change of a constant function is 0 because it's not changing, because it's constant, right? So that makes sense. But if you have a constant multiplying your function, then you just pull it out and multiply the derivative by that constant. Any other questions with that one? Is that all right? So it's getting a little bit easier, right? Little bit.